We will attempt to use a more accurate method to first of all estimate the equation of the regression line and then use this equation to draw the regression line on the scatter plot. The motivation for doing this is as follows. The regression line is a straight line, and as such, its equation will have the general form y equals mx plus c. So y equals mx plus c is a general equation of a straight line. And this form of the equation is called the slope-intercept form. Because in this form of the straight line, the slope is given and the y-intercept is given. The y-intercept is the point at which the line cuts the y-axis. As mentioned, the equation of the regression line follows the same general format but is written slightly different. We'll write the general equation of the regression line as y equals a plus bx. And these two formula are basically the same, except that in this one, we choose to write the y-intercept first, then followed by the slope. So a is the y-intercept and b is the slope. A and b are constants, and b is specifically called the regression coefficient. The regression coefficient. The aim is to estimate the values of a and b using the data from the table or from the scatter plot. The method used to estimate the values of a and b is called the least squares method, and this method is usually abbreviated as OLS, which stands for ordinary least squares. The least squares regression line is the line that makes the sum of the squares of the vertical distances of the data points from the line as small as possible. Again, the least squares regression line is the line that makes the sum of the squares of the vertical distances of the data points from the line as small as possible. Now, this is a mouthful, but we can take it part by part and analyze what exactly it means. In this scatter plot, we have some data points and the regression line for the data points. Each one of these data points is called an observed value, and the corresponding location on the regression line is called the predicted value. So this is the value that we actually observed, while this point is what the least squares model predicts the point to be. In this case, our observed value is larger than what the line predicts. For each one of these observed value, we draw a vertical line to the best fit to the regression line at the particular predicted value. So observe, predicted, a vertical line. And the distance then, this vertical line represents the distance between the observed and the predicted values. And this distance is called the residual. And the idea behind least squares regression is that we have to position this line such that the residual, when we square each of these residuals and we add them together, we get the least possible value. And once that is achieved, then the line is going to be the least squares regression line. So to make it a bit simpler, let's call this distance here d1, d2, d3, d4, d5, d6, d7, and we wouldn't get a d8 because this point lies exactly on the line. So the observed value is the same as the predicted value. And as such, we wouldn't have any residual for that data point. Now, because some of the data points lie below the line and some lie above the line, this means that sometimes the distance would be positive and at other times the distance would be negative. So D2 would be positive because it's above the line. D5 would be positive and D7 would be positive. D1 will be negative, D3 would be negative, D4 would be negative, and D6 would be negative because they lie below the line. And if we have to add these values together, D1 plus D2 all the way to D7, then we will get 0 as the answer. So the best fit line, because it's as it is, when we add the distances above the line and the distances below the line, we get 0. And remember, each one of these distances is called a residual. So what we found here is essentially the sum of residuals. Instead of adding the residuals together so that we get 0, we're going to square each one of them first. So d1 squared, then d2 squared, all the way to d7 squared, and then we will add them together. And because we're squaring each of these residuals, we're guaranteed to get positive value. So this here will work out to be a positive value. And when this positive value is at its minimum, then the line which causes that to happen will be the least squares regression line.